Verilog is not a programming language, at least not like any that you are used to. It is a hardware description language, which means it is a textual way to describe digital circuits. Since you might be new to digital circuits, let me make an analogy. Imagine that you wanted to describe how your bedroom is organized to a friend over the phone. You could come up with a bedroom description language that could describe the size of your bedroom and the location and orientation of all the things inside your bedroom. This is very much like what Verilog is, except it describes circuits instead of bedrooms. In Verilog, circuits are called modules, and we use Verilog to describe how we can make each module out of other modules. The first step to describing a module in Verilog is to mark the beginning and end of the module's description with module and end module statements. We then need to give the module a name. Sometimes I place a comment at the end module statement to make it easier to match these up when multiple modules are in the same file. Next, we describe how the module connects to the outside world using what are called ports. Our example module has 3 ports, and each of these needs to be given a name. We then tell Verilog whether these are input ports or output ports. Notice that when I listed the ports on the first line, I put the output ports first, which is a common convention. Next, we'll describe our module by what other modules it is made up of. Verilog has built-in primitives for AND, OR, and NOT gates, but we instantiate them the same way we would any other module. Whenever we include a module, we need to specify the name of the module, give the component a name, and specify how the module is connected. So for our OR gate, I'd write OR first. The component name is used during debugging, so I'm going to give it a name that is unique and makes it clear that it is an OR gate. I'll use O1. To connect the ports, I need to know how they are ordered in the module's definition. Verilog's built-in modules follow the convention, so the output port is first, followed by the input ports. So let's see how to connect this OR gate up in our circuit. We instantiate it in our module and we see that its inputs connect to our 2 input ports, X and Y. So we write X and Y in the input port definition of our OR gate, indicating that the OR gate's inputs are connected by wires to our module's inputs. But our OR gate's output connects directly to our AND gate. To handle this, we need to declare a wire. For our module, we need to declare 2 wires, which I'll call OR wire and NOT wire. Now I can connect the OR gate's output to OR wire. Similarly, I can instantiate the NOT gate and connect its input to Y and its output to NOT wire. Lastly, I can instantiate an AND gate, connect its inputs, and connect its output to the output port O. So you can see there is a clear correspondence between the Verilog I wrote and the circuit. And this is how you should think about Verilog, that it is a textual way to describe a circuit and not as a program to run. Let me further clarify 2 common misconceptions. First, the order that we instantiate modules doesn't matter. Our module instantiations just describe how things are connected, so we can change their order in the file without changing the topology. Second, students that are used to normal sequential programming are comfortable with reusing variables. For example, in many languages, I can add 1 to a variable with the following statement. This tragically leads some students to try to reuse wire names, thinking that it would create a circuit like the one shown. But Verilog will connect all module ports with the same wire name within a module, meaning that the resulting circuit will really look like this, which isn't what anyone would want. That's it for now. Good luck.